we need to realize that example number 1 is a quadratic equation because the highest exponent is of a variable is 2. That's all it means. The highest exponent for a variable is 2. Okay, quadratic equation we have right here. The variable x has the highest power of 2, so we're talking about quadratic equations. And then we're going to talk about completing the square in a little bit. But look at this problem here. Normally, what do I tell you to do if your highest exponent is 2? Move it all to the left. If I were to do that, I'd get a positive 2 here, and I would be stuck. I'd get stuck right here. But I don't know if you guys look at this trinomial right here, but it is a special trinomial. It's a perfect square trinomial.
What?
So if you're like, what's a perfect square trinomial? Do you remember the yes, yes, yes? Yes. All right, is this a perfect square? Is that a perfect square?
Yes.
Is this middle term the square root of this times the square root of that times negative 2? So is it x times 3 times negative 2? So what's this? It's negative 6x. So we say yes, yes, and yes. That's review. Okay, if that's true, something happens. I can factor it immediately into a binomial square. Does anyone remember how to do that? Beth?
So you do the x and then you take the two factors of 9 that add up to
Okay, so and really you could do that, and what are you going to get? Yeah, the same number, minus 3, right? That's why you do x minus 3 squared. Good, good. That's, yeah, you could derive it that way. And I still have this equals 7 part, so that didn't just disappear. And when I'm solving an equation, what am I looking for? The value of, in this case, I want to know what x is. But right now, x is being subtracted by 3 and then squared. So what undoes that process? What undoes squaring? I'm going to square root the left side, but what I do to one side, must do to the other. When I square rooted both sides, I created 2 answers. 2 answers here. Okay, so let me show you what the result of this squaring would be. It'd be x minus 3, right? The square and the square root, they cancel each other out. But then on the right side, I got plus or minus the square root of 7. I created 2 answers. Remember that with Pythagorean theorem?
Yeah.
And normally with Pythagorean theorem, do we need the negative version? No. But here we're not dealing with a triangle. We're dealing with actual mathematical terms. So I'm going to keep that negative. But I need context. What is the square root of 7 approximately? Can someone just give me an approximate? Walker?
3.25.
Okay, 3.25, 3.3?
I meant to say 2.2.
Okay, 2.2 makes more sense. So how many of you are in agreement? It's between 2 and 3. 2 and 3? Closer to what? 2 or 3?
3.
Okay, a little bit closer to 3, so maybe 2.6, 2.7, 2.5. Okay, 2.7. I'm going to go 2.7. Okay. There you go. Good estimating there. I hope you're right. All right, but did I get x by itself yet? Now, what do I have to do to both sides to get x by itself? Add 3 to both sides. Okay, now what you have to be careful of, square root of 7 and positive 3, can those just combine?
No.
They're not like terms, so don't just merge them together somehow. But this is what I'm left with. I have x on the left. And then the proper way to write this answer is to write the rational part first, then the irrational part second. So I got 3 plus or minus the square root of 7. You're like, what does that mean? What a great question. This plus or minus sign is showing me 2 separate answers. It is showing me x is equal to 3 plus the square root of 7 and 3 minus the square root of 7. These are my 2 answers, and I need you to write them like that, separately. They're my 2 answers. Yes, ma'am?
Do we always put that sign
This plus or minus?
on these problems, right?
You're always going to have a plus or minus when you square root both sides. Yep.
But we didn't do that last time.
We did do it with Pythagorean theorem and distance, but with distance and Pythagorean theorem, can you have a negative distance? No, so we take that negative off. But now we have to realize, no, we do need them in these problems. Yep.
I'm just a little confused on how you got from x squared minus 6x plus 9 and x minus 3. What did you do? Or
We factored it, and no. I think Beth gave it to us in a good way. If you didn't understand it right away, how would you factor this out? You'd get an x and an x. What two factors of 9 add up to be negative 6? They'd both be those. So really you can write it not as x minus 3 times x minus 3, but just x minus 3 squared.
But they're not always going to do it.
You know what I'm going to do? This lesson is about taking something that is not there and forcing it to be there.
Oh.
You're going to make things happen. Is that scary? So, I'm sorry. You're going to take something that, wait, you can't do that there. Make it happen. Make it happen. And that's the cool part about completing the square. Okay, how many of you went from this step to this step and you're okay, where you got x minus 3 squared equals 7? How many of you are okay with square rooting both sides and getting 2 plus or minus the square root of 7 and then getting rid of that squaring? How many of you are good with adding 3 to both sides? Okay, and how many of you are okay with me saying that this can be broken down into 2 parts? Okay, we said that's about 2.6. What's 3 plus 2.6?
6, 2, 5.
5.6. Good. Yes, 5.6. What's 3 minus 2.6? 0.4? 0.4? 4/10? 3 minus 2.6 would be about 0.4. So you got 5.5 and about half. 5.5 and half. We're estimating. We're not getting exact, but we're trying to make sense of what our numbers are. Okay.
Wait, so they're two different numbers.
They are 2 numbers, and both of them work for this equation. That's the cool part of it. Now, let me ask you this question here. I call these quadratic because the highest exponent is
2.
Okay, how many of you, just by looking at the problem, knew that you could have 2 answers? And can somebody tell me how you saw that? Like, did you just felt it could have 2 answers? Or is there something telling you, yep, it could have 2? Margo?
It's because the variable has 2 of the exponent, so you know that's really high, so it has to be that.
So you can have up to 2 answers because that highest exponent is 2. Yep, that's it. You can have up to 3. If you have 4, up to 4. And you can keep going on and on. If you have just a 1, you can only have 1, up to 1 answer. Now, does that mean you always have 2? No, sometimes you can have 1 or none. It's not possible to get an answer in this case for certain problems. Yes, sir.
But then when you square rooted it, didn't you open the possibility for a wrong answer?
Yes, I did. Yeah, and that's good. And what's cool about these two is that they're called conjugates. One's positive, one's negative. Everything's the same except that plus and minus. So what happens over here with the squaring is that it doesn't affect it in that way. So it kind of undoes that happening.
You didn't even check it.
On these problems, if you can get to that part, you're good. You can technically check it, but look at your check. You're going to have to put this in here for x. And it's not like you can't do it.
But you told us that in no other circumstances we cannot be able to.
Excuse me? So you could do that if you had time, but I would say go through this process. You should be fine. But good question. Good question, guys. Okay. Let me give you... Okay, Beth?
Okay, that is the other formula is the
Perfect square trinomial?
Yes.
Mhm.
If it's not that,
Make it that.
I don't know how to do
We haven't gotten there yet. Yeah. So far, that problem, Beth, it gave it to us. So be thankful, take it. And by the way, guys, it's funny because I'm going to give you a problem and see if you're thinking. You can go a long route or you can take the short route. And we'll see how you do. Does anyone know what x plus 5 squared is? Okay, x squared is your first term. Everyone okay with that? Yeah. How many of you are good with your last term being positive 25? How many of you know what the middle term would be? Hayes, what do you got? Yeah, positive 10x.
Why?
Okay. Oh, x. Okay. What isn't this right here? X plus 5 times x plus 5.
Oh, FOIL.
Yeah. X squared. 5x gives me. And then 5 and 5 is 25. No, that's okay. No, it's a good question because you have to do it on your own as well.
Well, yeah.
So that's good because you'll know hopefully what to do. Okay. There is a pattern to go from here to here directly, like just to be able to go from here to here. And there's a pattern to go from this trinomial to this binomial directly. But that's not what I'm going to talk about today. Okay, look at this perfect square trinomial. Can we do that? It's in descending order. And I want you to look at the middle coefficient. So the coefficient of x. What is it? Write this down. It's 10. It's 10. Mm-hmm. Sorry, it's just that number right there. You just pull it down, make it 10. All right, watch what we're going to do to this. I want to cut it in half. How do I cut it in half?
You split it.
Yes, you divide by 2. Yep.
It's 5.
Yes, it's 5. Thank you. And then what I'm going to do is I'm going to square that value. So what's 10 over 2 squared?
100 over 4.
Just 20.
This process that I went through gave me what? That number right there.
Sorry.
So what's 10 divided by 2? 5. What's 5 squared? What a great question. Let's do another problem. I want you to see a pattern, and then I'll give you the reason why. Yeah. It's not that I'm trying. It's just it just happens. I don't know how to answer that question. Let me give you another one here. X squared plus 16x plus 64. Okay, is that a perfect square trinomial? Okay, yes, yes, yes. So this is x times 8 times 2, 16x. All right, we're good with that. Can someone factor it? Right away, go. Taylor. James, I see that hand. X plus 8 squared, that's it. Sorry? Sometimes you get, so we're just dealing with this, but then I'm going to put the equal sign soon. But here we're just changing this and factoring it. We're just factoring. Okay. You guys comfortable doing that? Taking a perfect square trinomial, getting to a binomial squared? If not, you'll get more practice with it. I'm going to erase that because I need some space here, and I don't want to confuse with the next thing I'm doing. Okay, ready? Look at this number in the middle. Remember, it's in descending order. I have that 16 in the middle. All right, what do you think I'm going to do to it? Divide it by 2. And then do what to that? All right, what's 16 divided by 2? 8. What's 8 squared?
64.
Okay, how many of you see maybe a pattern?
Yeah, like what is that?
Why?
What does that do? What? You're doing what's on. What do you mean?
And how? Wait, I have a
256. 156.
Wait, I have a question.
Go ahead, Josh.
So, how can you just do that to the denominator?
Oh, so I'm not changing values. All I'm trying to say is that these two numbers relate in this way. I'm just saying they relate. I'm not
Wait, can you
changing
simplify
anything.
the problem to that?
Sorry?
Can you simplify the problem to that?
No. I see what you're saying. No. But watch this, guys. Ready? Can you do this for me? What's that number?
X squared 16.
Okay. If you did not know this number, how could you find it? You would do 16 divided by 2 and then square it, and you would get your positive 64.
Because what?
Okay. I have several questions, and I can't hear any of them.
Okay.
Ellie.
Is it not like kind of what you're doing, but like reverse, because you have to multiply by 2?
Yes. You're reversing things, right? Remember how I multiplied by 2 after multiplying those two outside numbers? This time I'm dividing by 2 and square rooting. So it's the reverse, or squaring, excuse me. I'm squaring instead of square rooting. I'm doing all the reverse. Yeah, good point. I didn't even talk to the other class about that. Ready, guys? Here's what I want you to do. So you're like, why do we keep talking about this?
I don't get it.
This is our homework.
What is your life today?
All right, find what the value of C is. I want to know what C is. Don't tell me what it is yet. I want people to figure it out. I see that hand. Okay, Taylor, in just a moment, you're going to give me how you got it and then what you got. So I want to find out what C is, and some of your homework is going to ask you find what C is by completing the square. So right now, guys, is this a perfect square trinomial? It's not, because I don't even know what C is. Can I make it a perfect square trinomial?
Yes.
This is your goal. All right, Taylor, what'd you do?
You bring down -6, and then you divide it by 2, and then square it. It's 9.
So this number right here is equal to 9.
But always?
Well, in this problem.
But always?
In this problem. I don't know what you mean by always.
Like, could you?
You can always do this process, yes.
Okay.
Okay, now guys, I got what C is, and this next part is extra, but it is part of your next type of problem. Can you guys take this perfect square trinomial and factor it into a binomial squared? What would it be? X minus 3 squared, right? You can do that? There's another relationship. What's this number inside? -3.
What was that? I have a question.
Okay, I'll take questions here. Yes, sir.
With the perfect square trinomial, x can be squared into x, and then 9 can be squared into 3. And then what's the deal for the middle term here?
The negative, since it's a negative, it becomes -3. Sorry. If this were positive, it'd be +3. So the middle term,
But how do you know it's like a perfect?
because it has that same format. So like if I take this right here and did this, I'm going to end up with x squared minus 3x, which is minus 6x, plus 9. It's just a pattern you keep seeing with those, which is cool because then you don't actually have to work it out every single time. But that -6x is there. It's just, you don't even have to think too much about it. You just write it. Boom, got it. Okay, let me do this. Has this worked kind of nicely so far? Like it's just like, oh wow, you can do that, get that number, but it doesn't always work so well. And I guess I'll just go to the next page. Let's look on page 746 and look at number 6. It says find the value of C that makes each trinomial a perfect square. All right, I want to find a value for C that makes this a perfect square trinomial, but I have a problem. I have an odd number, and those aren't easy to divide. But let's see here. Okay, guys, I want to find this number. What number do I use? -7.
Over 2.
Divided by 2. Square it. Now, in your book, they're going to give you decimal numbers. I don't want decimal numbers. I want fractions.
Yeah.
Fractions. I like decimals for some things. Fractions. Excuse me? Okay, good question. Improper fractions, simplify it as much as they can. All right, what's -7/2 squared? Positive 49/4. This number right here is positive 49/4. Yes, leave it like that. That'll help you to use it in the next step, which I'm going to show you right now. Okay, how many of you are good with taking -7 and dividing it by 2, but don't actually divide it, just leave it as a fraction? Okay, how many of you are okay with -7/2 squared is -7/2 times -7/2, which is positive 49/4. That's the number that goes in there. That's what you do. Okay, but I'm going to take it another step further. So this is your answer on that problem. That's your answer. So let me take it one step further in just a moment. Let me get your question in just a moment. Can you guys factor this into a binomial squared?
I mean, you technically yes.
Immediately you can do it. Boom, you got it. Hayes. Yep, a minus 7/2 squared. That's it. How do you get, what'd you do wait, what's the square root of that?
7/2.
Negative 7/2, and that's it. That's your binomial squared. Do you guys see the relationships there? Okay, they're not just random like, hey, let's throw out some numbers and hope you get it. Okay, I'm going to test you out a little bit and see if you guys can figure this out. Don't turn to example 2, so most of you are on page 746. Don't turn to this one, but I'm going to give you those problems because if you can do those, you're on a good path. So example number 2, this is a x squared plus 20x plus c. 20x plus c. Find what c should be to complete the square. I'm going to let you guys kind of do this until you get it.
Okay.
I want to find what c is so I can complete the square.
Okay.
All right, I took 20. What do I do with it?
Put it on over 2 and then square and you get 100.
Mm-hmm.
And then you have to plug it in.
Oh, and you can. That's your answer for this problem. You're done. Done.
Okay.
You guys okay with that one? How many of you got c equals 100? Okay, so when I made c equal 100, and I'm going to put it in there so you can kind of visualize it. When I put c as 100, what I did with this is now I made this into a perfect square trinomial. And why is that even? So a lot of the questions were, why do we do this? Because you can factor a perfect square trinomial like that. So can anyone factor this trinomial into a binomial square? Go. Done. That would have been your next step, but that's not part of this answer in particular, but that's your next step on these problems coming up. Okay? Sorry?
That would have made my life a lot easier.
Yeah, and see, the first time maybe some of you like this just passed over you, or it's like, I don't like it, and now you guys are just quick on it. It just takes time. And if you get it now, great. Yes, ma'am. All right, B, and then you guys can do it. Go ahead.
You said that the thing was 10 on this one.
Yeah, B plus 10, I think.
The x plus 10.
Oh, X plus 10, uh-huh.
And then on the other one it was minus 7/2.
Mm-hmm.
But that,
So,
because this one, why wouldn't you put 20 over 2?
okay, you could write 20 over 2, but what is 20 over 2?
It's
So that's how I got it, yep.
you
So
can't.
simplify it. You can't simplify the other. Good, good. Yep, so you saw that pattern. Okay, B, don't look at it again. X squared minus 15x plus c. Find out what c is.
Why do they use C?
Constant.
Okay.
That number does not have a variable next to it, and so we can call it a constant c. Although constant in math a lot of times is k because it's a German word constant, which is k. Constant. Yes.
C is a variable.
Yes, it is a variable. But it doesn't have an x with it. And really, when you find out what c is, there's no more variable there, right? Your whole goal is to find what c is, but then c won't have any x or y or anything next to it after that. It's a constant. It's just a number. Here, you see how you have 15 or negative 15, but it's still next to the x. And here you have a 1 next to x squared, so those are all not constants. They can change. X to the, sorry? You could say that, but you understand you can drop that out.
Okay.
Okay.
Zero is
All right. Negative 15. What do you do with that?
minus 2 and then square root of 2.
And then you get 30 over 4.
No. So you get 225 over 4.
Oh, it's no longer now.
Yeah. Do you notice that these C values are never negative. Why are they never negative? Because you square them. If they were negative, you did a negative times a negative positive. If they were positive, it's a positive times positive, positive. So they always end up being positives if you did it right. Now, how many of you knew 15 squared? 15 times 15 is 225. How many of you did not know that? Did not? Okay, ready? What's 15 times 15? 225. What's 15 times 15?
225.
What is 15 times 15?
225.
So maybe one, maybe two, maybe all now know what 15 times 15 is?
225.
You know how I did it? Just kept saying it. 15 times 15. 15 times 15. Hold on. This little guy is pointing at Harper. So I will ask Harper this question. 15 times 15? Okay. So we're going to ask Harper tomorrow. Can we do that?
Yes.
It'll be fun.
Memorize it.
So I'll be teaching. I'll do this kind of in a fun way. I'll be teaching 15 times 15. 15 times 15.
How do you know which person you're pointing at?
Maybe that was Eli.
Actually, you know how I can figure it out? This is like a giant mirror. Saw that paper. Beth just raised her hand. See you're waving your hand. Yep. Hi, Benton. Hi, girls up front. Thank you, Kendall, for not doing anything you're not supposed to. Okay, it's a giant mirror. A green mirror.
So you're always like that.
I always know what's going on. You know the eyes in the back of the head? You know it's funny? You know how teachers have eyes behind their heads? Okay, this is how we do it. So I'm working up, and then in the corner of my eye, I see something like fly, for example. Okay, I see something fly. So I turn around, and then they're like, how do you know it's me? Because you have a face like this. So the people who weren't doing anything are just kind of looking, and then the person who's guilty, you did it. How'd you know it's me? Eyes behind my head. You gave it to me. Thank you. Or some people are, straight face like nothing happened, but everyone else is reacting. What did you just do? And figure it out. Okay, anyway. Can somebody do this for me? Factor that out. Now. So where am I getting the 15 halves? It's the square root of that, and it's negative because that middle term was negative. Okay, because you're going to have to do both of those. Okay, I think you guys are getting that down. That's what we call completing the square. So I had an expression with no third term, or I have a third term that is not what I want to make it a perfect square trinomial. When I come up with that third term, I completed the square, and completing the square is good. Yes. Emphasis on good. Yes.
You know how there's Swivl for binomials?
Mm-hmm.
Like, is there such thing as something shorter for binomials? You just have to do 2 steps?
Yeah, like if it's a monomial times a monomial, you call it.
But what if you could
Do it. Yeah. Yeah, you can call it. You can make up stuff.
Technically, you can do full except FOIL because you don't need one of the X or
No, that's okay. That's all right. Yes, you can come up with other acronyms. Okay, let's look at example number 3. Here's where we're going to put it to the test and see why in the world do I even go through this process. So x squared plus 8x minus 18 equals 0. So this is what our whole lesson is about. It's completing the square so that I can do what? Solve an equation. So we've been completing the square. That's great because I'm going to need that. I can factor. I'm going to need that. But I need to solve the equation for x. Okay, so I'm looking at this now. And do you guys remember our method? We get everything to the left, and then we try to find two factors of negative 18 that add up to be 8.
Can you add something to it, right?
Yes, you can, but let's go through that just a bit. Yeah. Because can you guys know any? I don't have anything. My mind's blank. Sorry, 4 and 4?
No.
So that's not going to get me 18, unfortunately.
I mean, yes, it will, because if you add like 18
Sorry.
plus another 16, that would be
I'm drawing a blank because nothing will work. I can't factor it out into two binomials. So what I can do, though, is I can do completing the squares. This is what I'm going to do. I'm going to get rid of the constant, the one without a variable. How do I get rid of that 18? I'm going to add 18 to both sides. I'm going to get it over to the right side, and I'm left with x squared plus 8x blank equals 18. Now there's a blank there, and why would I do that? Because I want to find a number that I can put in here that would complete this square. Because then I can work it out, and then I can get an answer. Because right now I'm stuck. This is it. That's all I have. So does anyone know what number should go there?
16.
Did you guys do 8 divided by 2 squared? So that's 4 squared. That's 16. Now listen, guys. Here's your understanding of equations. I can add 16 here. That's all right. But what else do I have to do?
Add 16 to the other side.
I got to balance it out by adding 16 to the other side. If I just add 16 to the left, I work it out, I get an answer. It's wrong because I got to do it to both. Yep.
So what's wrong with me adding 34 on the first one with the negative 18 and then add that onto the 0?
Yeah.
Okay, you're adding 34 here and 34 there? Okay, how'd you know it's 34?
Because I had to make that one 16.
So you had to
You need to do what you're doing here.
yeah, you gotta find that process anyway. But don't make it too hard. You could do it. And again, you guys are thinking, well, but watch what happens with this process here. It's kind of a neat process. Can I factor this out right now? Is it a perfect square triangle? Is it yes, yes, and yes?
Yes.
Mm-hmm. So what's that binomial
4.
squared? X plus 4. So does this factor here? Now, how did I get this plus 4 right here?
Because it's right.
It's right there. It's right in there. And what's 18 plus 16?
34.
34. So there's your 34. Okay, don't do anything yet. Look at example number 1. Look at the second step in example number 1. How many of you were able to successfully go through example number 1? You're doing example number 1 from this point on. So go back to your problem. And I have x. It's being added with 4 and then squared. So how do I undo the squaring first? Square root both sides. When I square rooted both sides, what happened with my answer? It became 2. I get 2 answers now. So I get x plus 4 equals plus or minus the square root of 34. And the square root of 34, that's absurd. That is just a dumb number. What is the square root of 34 approximately? To the nearest whole number.
6.
It's about 6. We'll use it as 6 in just a bit. Okay, so here I get my my next step, but then I want to get x by itself, so what do I do? How do I get rid of that 4? Just subtract 4 from both sides. Can I just combine these like that? Nope. I'm going to get x equals negative 4 plus or minus the square root of 34. And then how do I want to write it? Yeah, how do I want to write it? Right there. So separate it. Little did you know that there are 2 concepts that we introduced here, and I'm not going to get too in detail. What's the difference between these 2 expressions? One is being. There's something cool about when you multiply these 2 together. We're not doing that today. They're called conjugates of each other, and when you multiply them together, you don't have any more square roots. You got rid of the square roots. It's really cool. That's a separate idea. But then, what is negative 4 plus about 6? What's negative 4 plus 6? 2. What's negative 4 minus 6? So you got 2 and negative 10. Is that reasonable? 2, negative 10? That's all you're saying there. And someone asked a question. I don't know if was it you guys or maybe. Oh yeah, it was this class. Do you check it? You can check it.
Oh, that was me.
That's up to you. Hey, did you have a question?
Do we just put b plus 5 sine?
On your work you can, but split them up for now, and then soon I'll have you just write that. Well, next year you could do it.
Oh.
Yeah, you'll get it.
Wait,
I know.
say dividing like 5 by
Yeah, so maybe next month I'll let you do it. Okay, yes, Beck? Ah. Go ahead.
Okay, but why can't you put the 4 like?
After?
Yeah.
I mean, you could, but the proper format is to have the what we call the rational part, then the irrational part. So that's a format. And that's, wow, this is actually alluding to imaginary and real numbers. Because you're going to have to write the real number part first, then the imaginary part first. That's standard form. So this is kind of relating to that. Yeah, that's cool. That's Algebra 2. So yeah, this number is just in your mind. And are all my numbers in your mind? Yeah, that's their ideas that we can put into symbols and then work them out. Okay, that's your answer on that one. Let's see if you guys are paying attention. I'm going to give you one problem here and see how you do. Here it is. Wait, no, that's that good one I had.
You should write with the eraser.
No, I had a good one here, and when the other class did it, I can't. Okay, here it is. Number 7 on page 746. Number 7. Yeah, so I didn't write this problem down. I want you to solve x squared plus 4x plus 3 equals 0. And all I'm telling you to do is solve. Just solve it. Whatever way you know. Don't say anything either. I don't want any clues. I don't want any hints. I don't want any help from anyone else. Just do it. So what do you? I mean, that's actually an imaginary number, but yeah, it shouldn't come out to that. Now, did you add this? Did you add that to the
Oh wait, no, I can't do that because of the thing we have to do.
binomial? Yeah, I would say one thing that a lot of people are forgetting is when you add something to one side, you got to do it to the other. You can't just say add here and then leave it alone. Yes?
On this one, how did we go from this to this?
You did 8 divided by 2, and then squared it to get 16. And then to get to this binomial squared, you get it's going to be x, the square root of that, and the square root of that. And then it's plus because that was a plus. The middle term was a plus. So it's kind of like square root plus square root.
So it would be on this one.
I know.
On this one.
Yes. I won't.
Oh, wait, you can do it that way.
Is that the answer?
I got it. What's the
Oh, I didn't know you could do that.
Uh-oh.
I got the answer.
You just factor it and then find those numbers. Okay, how many of you are doing completing the square? Good. Let's go through that.
Wait, can we do it on average?
No. Only if it works. In this case, it worked. All right, how many of you did completing the square? You're starting to okay, let's see what happens. All right, I get my x squared plus 4x. And then how do I get rid of that 3? I get this, right? Okay, I want to figure out what this number is right here. So I take that 4 divided by 2 and then square it. What's 4 divided by 2 squared? 4. So I got positive 4. Here's what you missed if you maybe didn't get that far. You added 4 here. So you should Add 4 on that side. Don't just leave it alone. Got to do to both sides. Okay, what is the binomial squared, or what's the factoring of this? X plus 2. And then here, I get my 1. Mm-hmm. Square root both sides. I just introduced 2 answers. So I get x plus 2 equals plus or minus, what's the square root of 1? 1. What do I do to both sides? Subtract 2. So you can think of it like this. X equals negative 2 plus or minus 1. What's negative 2 plus 1? Negative 1. What's negative 2 minus 1? I mean, what some of you got. How many of you did it the quick way? How many of you did it? How many of you still got it completing the square? So can I say, okay. How many of you didn't finish? How many of you would have gotten this maybe if you had finished? Okay, that's all right. You know what's nice about it? You didn't have to do completing the square. You could have just done factoring. Okay, we'll go through another one to make sure you guys are good. What questions do I have on this problem? Like, what did maybe you miss? Or what are your questions, like how to do this or that?
Is
Yes.
that kind of a rare one? Like, should I not?
Yeah, if you always did completing the square, you'd be fine.
Okay.
Yeah, just go complete
That
the
was
square.
just kind of pointless.
Not pointless, it's pointful.
Okay.
Yeah. I don't know what to say. Pointful. All right. Yes, Harper.
Why did you do like the why could you do the to get that?
That's here. The other method or this method?
When you did negative 2 plus 1.
Uh-huh.
Could you do that with the last one where you go?
Yes, but those two numbers don't combine anymore. These two numbers can combine. Like if I had the square root of 3, I would just leave it negative 2 plus the square root of 3, negative 2 minus the square root of 3. So that's all I can do. But in this case, I can combine them.
Could I leave it would you count off if
I would count off like 1 point on that on a test or quiz. Yeah, but not all of it. Yeah, if you get to this point, I'm like, yeah, maybe she almost had it. But you can make that simpler by writing it like that.
1 point or 1%?
Ooh, that's deep.
There's a big difference.
No, go right on my leg, Margo.
Okay. Number 22. Let's do that one together. Number 22 on page 746. 22. Plus 14 on minus 9 equals 6. All right, so this one's a different variety, but we haven't encountered it before. Yeah, let's just go completing the square. Just go for it. Okay, so I have my trinomial, but is it a perfect square trinomial? No. So I can make it by doing what with that constant? Just getting it out of there, adding or subtracting whatever you need to do to undo that problem. R squared plus 14R blank equals 15. Okay, that was my first step. I want to fill in that blank by completing the square. So what number am I going to use? 14. What do I do to it? Divide it by 2 and then square it. That's complete. That's what we call completing the square. Okay, bless you. What's 14 divided by 2? 7. Squared? Okay, I'm going to add, by the way, it's always adding when you complete the square. When I add 49 on the left,
You have to add all the
add 49 to the right. I got to keep this balanced. It's a balanced beam, and you added weight here. You got to add weight there to keep it an equation. Okay, can anyone factor this guy out? What's R squared plus 14R plus 49 factored? R plus 7 squared equals
64.
Ooh. 64. Interesting. I like 64 because it should trigger in you what? What's it trigger it? What's 64? It's just you start thinking I could get the perfect square. Okay, hold on. What do I do to both sides? We're going to finish this, then I'll let you go. Square root it.
R plus 7 equals 8.
Plus or minus 8.
Oh, yeah.
Plus or minus 8. Because you got two answers. You subtract 7 from both sides. Last problem, we're almost done. R equals -7 plus or minus 8. So somebody tell me your first answer, -7 plus 8. Josh?
1.
1. Second answer, Benson, -7 minus 8. Those are my answers. Okay, listen up, guys. I gave you a reduced homework load. It's not even, it's 6 problems. 15 to 25 odd. 15 to 25 odd. Listen to me, guys. If you struggle with this homework, look at the back and look at the answer and see how they're getting that. Try to go back and forth. That's okay.
Wait, don't go back and forth or
Do go back and forth if you're struggling. Yeah, I don't mind. Just don't write the answer and say, I got it, and then you don't understand it. 15 to 25 odd, page 746. Goodbye, guys.